Hello everyone. In this video, we will discuss the next multimodal LLM Phi-3-Vision. The Phi-3-Vision 128K Instruct model has been recently released by Microsoft as a part of the Phi-3 series. It has 4.3 billion parameters and it is mainly targeted for deployment on devices with memory constraints. Let us discuss it in more detail. The 128K indicates the context size of the input allowed. The architecture consists of a clip vision transformer encoder and the Phi-3 Mini 128K instruct as the decoder. The given image is tokenized by the image encoder and the text is tokenized using sentence piece tokenization, and these combined tokens are fed into the language model. You can watch how this works in more detail in the video on Polygamma on the top right corner. The Phi-3-Vision model was trained on a combination of image-text pairs from the FLDP 5 billion dataset that has 126 million images with approximately 5.4 billion annotations. The Florence models released yesterday also use the same dataset. Some other OCR synthetic data and images from PDFs were also added. In addition to this has been aligned for safety according to Microsoft's responsible AI principles with direct preference optimization. This model particularly excels in tasks like general image understanding, OCR, and extracting text from charts and table images. This model is lightweight and it has been developed specifically to run on edge devices such as mobile phones and web browsers. The 4-bit quantized version is smaller and it is easier to deploy on both Apple and Android devices. However, they can work only with CPUs and GPUs with RAM at least around 12 to 16 GB. For the deployment, the model has been optimized for the ONNX runtime, which stands for Open Neural Network Exchange, and it is available on Interface. This blog post shows the steps on how to download and use the models on a mobile phone or an emulator. This deployment usually works on higher end phones like Samsung Galaxy S21, Google Pixel that come with higher RAM. I will drop these links in the description, and if you have any of these phones, do try the deployment and let me know how it worked in the comment section below. Now let us try out the Phi-3 model in Google Colab. As usual, at the beginning we uninstall and install the necessary packages. The PEFT, which stands for Parameter Efficient Fine-Tuning, bits and bytes, and the accelerate packages are especially used for loading the quantized version of the model. We need to restart the session before we run the actual code. Now the package installation is done. Now let us understand the below code in much more detail because this forms the basis for loading any large model in Google Colab for free. Here with this code we are trying to download the 4-bit version of the 4 billion parameter model. Like I've already mentioned, since this is a 4.3 billion parameter model and it requires almost around 10 to 13 GB of memory to load, which is not supported by the free version of the Colab. This is why we are loading a toned down version of this model. The bits and bytes configuration object is initialized with the required parameters. We set the load in 4-bit to true, the quantization type to be NF4 and the data type to be bfloat16. With NF4 quantization, the weights are normalized to lie between -1 and 1 with 16-bit floating point instead of 32-bit. Then we go on to initiate the LoRa config object with the rank of the weight matrix, the names of the layers to apply quantization on. For example, if you see the Q projected, the K projected and the value projected are the query key value weights used in the self-attention. And finally, the task type is the causal LM for autoregressive decoder text generation. One other important thing to note here is that I have changed the attention implementation to eager instead of flash attention as given in the official code. This is because the T4 GPU does not support the flash attention and you need at least 100 to use it. We will understand all about flash attention in another video. But for now, let us say it is an optimization technique that makes the most out of the underlying GPU to save memory. So now, once we run this, we have loaded the model and the processor. Now the model loading has been completed and let's move on to testing. So this display image method is a helper method that is used to display the images that we are going to test. One more thing to note here is that this is a conversational model which can be used for chat purposes. The real advantage I see here is that you can use this to create a chatbot that can understand images and that can run entirely on the phone offline without relying on an API. Here, we are applying a chat template with a set of prior conversations and prompting the model to continue it with a new response. If you see, this is about a chart understanding task where the picture of a chart is given. So this chart is an image about how people perceive their preparedness for meetings. And based on this chart, there is a conversation here where we have sent a set of images. So the first message comes from the user, and then the assistant, and then the user. And then further, we prompt the assistant to continue this. So the assistant has to provide us with some insightful questions. Now let us execute this. Here there is a processor which is used to tokenize the image and the text and combine these tokens and then send it to the decoder. Here we are also giving some generation arguments such as the number of maximum tokens, the temperature and the sample. Let's see what questions we get from the model. Yeah, so here is the output. You do see that these questions are all about meetings and they ask some relevant questions to brainstorm further. And these questions do also make sense. So, for example, what do these percentages suggest about the general preparedness of individuals for meetings? And what strategies could be implemented to increase the percentage of respondents who have tools to manage admin tasks and various other criteria. So this is an example that has been provided in the official Hugging Face repository. I have only copied it from there and we have tested it. Now let us do some testing with our own images. And for this I've written a helper method. If you can see this get response from Phi-3, which takes the instruction from the user and also the image. So to Phi-3 we provide images as URLs instead of the base 64 version like how we did in GPT-4o. Understand this method further. So these are some of the prefixes that are mentioned in the official Hugging Face repository. And how it works is, first of all, there is a user clause which is followed by the image and then the instruction given by the user, and then the prompt suffix is end, indicating that the user's instruction has ended, and this tag prompts the model to further generate new tokens. We are also displaying the given image and then we send it to the processor and generate the output, and again we decode the output using the processor and then return it. That is what this method does. So here you could also provide some more context by sending multiple messages like how it's been done here. They have sent an array of messages, but here I'm using single image prompts just for simplicity. We also set the maximum number of tokens to 1000 so that the outputs are detailed enough. Okay, so let us use this method and start with image understanding. Like all the other models in this series, we start with the image of a scenery and ask the model to describe it. If you see, this is the image of the Greek island Santorini. And if you see the prompt, this is how it looks. There is a user tag, the image tag, the end, and the assistant. And now we get the response too. Let us print the response. So if you see, it says the image features a white building with blue doors and windows, surrounded by a variety of colorful flowers, including pink and white roses, yellow and red tulips, and white and pink carnations. The building is situated on a white tiled pathway, and in the background there is a clear blue sky and a body of water, which is all true. The model identifies almost everything in the image and also describes it quite well. Next, let us move on to text and handwriting extraction. In this task, again, like how we did for the previous models, I have uploaded an image of my handwriting and I'm asking the model to extract the text inside the image. If you see, this is the picture of my handwriting from a math assignment. It's not very clear, and at the same time it's not very ambiguous. So let's see what the model says. So here is the model's response. Sorry, I cannot answer this question. The image shows a handwritten page with mathematical equations and notes, but the specific text content is not clear enough for me to accurately extract and provide a detailed response. Okay, fair enough. So the model does recognize that it has math and equations, but it does not extract the text, saying that there isn't enough context. Now let us upload another image from a research paper and ask a very similar question. So here I'm asking the model to extract the text from a given image. Let's see how the image looks. So this is the image. So it has multiple choice questions from a paper, from a research paper, and I've asked it to extract all the text. So if you see, this is the model response. The image contains 4 separate sections, each with a question and multiple choice answers related to different concepts. And it goes on explaining what is the content of each section, but it doesn't necessarily print the exact text. So let us make this prompt a bit more specific. And this time, if you see, I'm asking, could you extract the question and possible answers of the fourth section from the given image? So I'm asking for this section. So let us see if the model will extract the text this time. You see, this is the model's response. And yes, in this case, if you see, it has extracted the question from the perspective of the driver of the blue truck. In what position is the person riding a bike relative to the blue truck? And the possible answers. A, all the 4 options, and the answer, and also the A math score. If you see the image, that is exactly what is there here, and it has extracted with along with the question name. So for this section, it does this correctly. Now let us move on to chart understanding, where the model is said to really shine. So this is again a chart from a research paper again, where different models are ranked and their accuracies are ranked in this line chart. So let us see what the model has to say about this. And these three types of performances are sketched here, which is the average performance and the performance on English datasets and the Chinese datasets. If you see, if you go down further, you can see all the names of the models that are being tested here. Let's see what the model has to say about this. So this is the response. My question was provide insights from the given chart. So the chart is a line graph titled this, and models are sorted with ascending order of average performance. And so it extracted the title, and it is also explaining what it is about. It displays the test split accuracy for different models in percentages with three lines representing the average, English, and the Chinese performance. It also tells us what is on the x-axis and the y-axis, and also what exactly the legends mean. It also summarizes the overall trend, which is a general upward trend, and finally it is telling us that there is a focus on average performance across English and Chinese. So this is quite a good explanation, I think. And now let us ask a question from the same graph. Here I'm asking, based on this line graph, what do you think is the best model? So it has to say this because the models are sorted according to the accuracy. They are plotted according to their increasing order of accuracy. So let's see what the model has to say. Yeah, so it says according to the chart, the best model is ILMX Composer 2, as it has the highest accuracy for both English and Chinese languages. If you see, if you go here at the end, you have this ILMX Composer 2, and yes, that has the highest accuracy for both, and for both English and Chinese. So the model has identified this correctly. Now, finally, let us perform one more task on chart understanding. This time, this is a graph from a paper on sustainable AI. This chart shows the energy consumption of training and using AI models. Let us see what Phi-3 has to say about this chart. So if you see, I've asked the model to explain this chart in detail, and like the previous one, it has first extracted the title, and it tells us what it is about. This is the main point. It compares the carbon footprint measured in millions of carbon dioxide equivalent of different machine learning tasks categorized into offline training, online training, and inference. And then it goes on to explain about the x-axis and the y-axis, and also what the colors in the graphs mean. It also says the graph shows that the inference tasks have the highest carbon footprint, followed by online training, and offline training has the lowest. The chart also includes a note that the operational carbon footprint of AI does not correlate with the number of model parameters, and that the OSS large-scale ML tasks are based on vanilla model architectures from a reference. So it has successfully understood what this chart is about, and also it is able to explain the main points out of it, which is the main inference out of it is that takes the inference tasks have the highest carbon footprint, and that which is what the model could identify from the chart. Yeah, so I would say in this case of chart understanding, the performance is really good. This will be especially useful in extracting text from images and PDFs. If you have worked with AI PDF summarizers, they're often not very good at reading and summarizing text, and they tend to exclude the images in the PDF. This is where this could really be of help. It could also be used to understand complex infographics. So on the whole, I personally find Phi-3's performance to be better than that of Polygamma. I mean, it could not extract text from my handwriting like GPT-4o, but this is only a small model and that to a quantized version. We will try this out with the full model and see if there's any change in the upcoming videos. Can the Phi-3 Vision model understand your handwriting? Let me know in the comments. Thanks for watching.